Hello, Luke. Welcome to Lesson 84. Today we're going to take a little detour and dive back into some statistic problems. And we'll be talking about stem and leaf plots and then histograms. So you recall in previous lessons, we've learned how to find the mean of a data set. We've learned how to find the mode of a data set, the range of the data set, and then finally the median, right? So we've learned how to find these four things given a data set. Today we're going to be kind of expanding on that and just looking at a different way to approach finding these things. So essentially, we're going to be trying to look at what happens if you have a large data set. Let's say you have a bunch of numbers that you need to find these for, and it can be a little tedious going through and organizing them and figuring out what the mode is, how many of them are given one value, figuring out the median is, which one occurs the most often, and so on. So let's just talk today about some strategies to visualize data and then find mean, mode, range, and median based upon that visualization. So to begin with, we need some data. So let's say we have this data right over here. Okay, so we have, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So we have 9 numbers right here. Okay, and we are going to use these 9 numbers and create what's called a stem and leaf plot. Okay, it's just a way to visualize a bunch of numbers. We're not really doing any math yet. It's just a way of kind of organizing the numbers that we're given. So let's take these numbers. The first thing we're going to do is take everything else except for the last digit. All right, so that sounds confusing. So we're taking the number, and which in this case it's the number 24, and remove the last digit, and what do you have left? You have a 2. Right? So we're going to call that 2. Maybe I'll write this out. We're going to have what's called the stem. And we're going to call that 2 the stem. Okay? And then if we go down to the next number, we have a 28. And again, just, ignore the last digit, but pay attention to everything else. And we have the number 2. Again, so instead of rewriting the number 2 for another stem, I'm just going to leave it the way it is. The next number, we have 18. If we ignore the 8, the first number is a 1. So now we have a 1 for a stem. All right. And then we have a 2 for the next, or I'm sorry, another 1 for the 10. And then we have a 2 for the 23, a 1 for a 5. And then finally we find a new one, which is the 3. And then we have a 28. The stem would be a 2. And the 24, the stem would be also a 2. So we really have 3 stems for this list of numbers. We have 1, 2, and 3. And I'm actually going to write those from smallest to largest. So let's do that. Let's write these from smallest to largest. We have a 1, a 2, and a 3. All right, so those would be all of the stems. All right, now the second part of this is we're going to have what's called the leaf, or if you want plural, the leaves. Okay, so there's 2 parts to this. We have the stem part and we have the leaf part. The leaf part is the last digit that we first ignored. All right, so for example, this first number, the 24, it has a 2 for a stem. So if we kind of line ourselves up with the 2 stem, we have a 4 as the leaf. Okay, and then we'll explain this more as we go, but let's just keep writing these out. We have a 28, which means we have a 2 for the stem, so we'll go to the 2 row here. And now we have an 8 as the leaf. So next to this 4, I'm going to write an 8. Okay? And then the next number, we have a 1 for a stem. We have an 8 for the leaf. So here's our 1. We go across from the 1. We write an 8. And then we have a 1 for the stem and a 0 for the leaf. Same thing. We go to the 1 stem across 0 leaf. 23 would have a 2 for the stem and then a 3 for another leaf. 15 has a 1 for a stem and a 5 for a leaf. 30 has a 3 for a stem, so now we're in the last row here. 3 for the stem, 0 for the leaf. 28, 2 and an 8. Well, we already have an 8 there, but we'll put another 8. All right. And then 24, we have the 2 and also another 4. Okay. So what we're looking at here is a stem and leaf plot. That's what this, if I were to kind of draw a box here and kind of connect all this, this is a stem and leaf plot. And usually we kind of separate the stem from the leaf. Okay? And it may look just like really crazy to you right now, but just don't get overwhelmed. It's simply a way of visualizing these numbers. Okay? And again, we start with the stems. We look through and we just ignore the last digit and look at all the stems. And we go, okay, the stems are anywhere from a 1 up to a 3. That's what we have here. So we'll have a 1, 2, 3 for a stem. The leaf is just the last digit for each number, and we just need to make sure we put each leaf with the right stem. All right, so the 4 was the leaf for the 24. It's got to be with the stem 2, so we have to make sure we're in that row. Okay, this is a stem and leaf plot. And we could perfect this maybe, make it even more organized by rewriting it. I think I'll do this. We're going to rewrite this. Okay, we're going to do our stem and leaf plot again. Only now, and we're going to have our stems, 1, 2, and 3. Kind of separate the 2 here. And then we'll kind of separate the 2 here. And then we have our leaves. So we have an 8, 0, 5, but now I'm going to write those from smallest to largest. So I have a 0, 5, and then an 8. 0, 5, 8. Okay. Then I'm going to write the 2 leaves from smallest to largest. So I have a 3, but then I have a 4, and then, let's see, 2 4s actually. 2 4s, and then 2 8s. So there are my leaves for my 2. It's good to kind of count up. I have 5 leaves here. Make sure I got all 5 of them there. Very good. And then I've got, for my, my 3 leaf, I've only got 1, and that's the 0. Okay, so there I've got it even more organized. All right, here is my stem and leaf plot. Now, how does this kind of help us? Well, it just helps us to visualize things a little bit better. All right, so now let's try to use the stem and leaf plot and try to find some of these statistics that we've talked about before. And let's start with the range. So if I wanted to find the range for these numbers now, with the stem and leaf plot, because it's all organized from smallest to largest now, the smallest number in our set is going to be the first stem combined with the lowest leaf. All right, so the 1 and 0. So the smallest number is going to be a 10. Okay, the 1 and 0. The largest number is going to be what? Can you tell me? What would be the largest number in this data set? Well, the largest number is going to start with the largest stem, and it'll go to the largest leaf of that stem. Now, there's only 1 leaf in here. It's a 0, so the largest number is going to be 30. All right? Now, remember, how do we find the range for a given set? We take the largest number and subtract the smallest number from it, right? So the largest number we just said was 30. So the range is going to be 30, and I'll just erase this so we're not confused. The 30 minus, we said the smallest number is going to be the 10. So 30 minus 10 is 20. So the range is going to be 20. All right. Now, you certainly could have figured that out by looking at the data set up here. You would have had to kind of look through it and make sure you found the largest one and look through it again and find the smallest one and then subtract the 2. But it is kind of helpful to have it set up in the stem and leaf form. It's just easier to find that smallest number and the largest number. All right. Now, if we want to find the mode, for example. Now, remember what the mode means. It means the one that occurs most often. This one we have to kind of look through, and we look for duplicates. So we have 0, 5, and 8, no duplicates there. We have a 3, 4, 4, and an 8, 8. So we have 2 4s and 2 8s. But remember, these are leaves attached to the stem of 2. So we have 2 24s, and we have 2 28s, right? The 2 4s and the 2 8s combined with the stem of 2. 2 24s, 2 28s. All right. And then the last one, we only have 1 0. So the duplicates are 2 24s and 2 28s. So we could say that the mode has a double mode. The mode is 24 and 28, right? Because they are listed the most. Okay? And then if we wanted to find the median, for example. Now remember, the median is the middle number in the group once it's organized from smallest to largest. So we have this organized from smallest to largest, and we know that there are 9 numbers. We counted them up in the beginning. So because that's an odd number, we're going to find what's the middle number in that 9. All right. And the middle number is going to be a 5, right? Because 5, plus 4 is going to be equal to 9. And then, the 5 minus the 4 is going to be equal to the 1 over here. So we have the numbers 1 through 9. And 5 is right in the middle. Okay, so 5 is the middle number. And so we just count. We go 1, 2, 3, 4, 5. So the middle leaf number is right here, the 4. So we've put that with its stem. And we know then that the median is going to be a 24. Okay? Now remember, just as a review, if there was an even number of numbers, so let's say there were 10 numbers here, maybe let's just throw another one down here. Maybe this one was 32, right? With a leaf of 2 with a stem of 3. So let's say there was a 10th number, 32. Well, then remember what you would have to do. What's the middle number? Well, there really isn't a single middle number because there's an even count. So if there are 10 numbers, we're going to take the middle 5, the 5th number and the 6th number. Right, so that would be the middle numbers. 1, 2, 3, 4, 5, 6. These two here would make up the 2 middle numbers. Notice we have 5 numbers to the left of it. Oh, wait a minute. Whoops, I'm sorry. Not those two. 1, 2, 3, 4, 5. I did that wrong. These two numbers. These two numbers are the middle numbers. Notice we have 4 numbers to the left. 1, 2, 3, 4, and 4 numbers to the right of them. 1, 2, 3, 4. So they are the middle numbers. But to find the median, you'd have to add them and then divide it by 2. Which in this case is still going to be a 4. All right, so just as kind of a quick refresher on finding the median. If it's an odd number of numbers, you just take the middle one. If it's an even number of numbers, then you have to average the 2 middle ones. Okay? All right, so that is that. Now, the only one we haven't talked about is the mean. And remember, the mean simply means the average. Okay? In this case, there really is no shortcut to this. Honestly, the stem and leaf plot doesn't necessarily help you too much with the average, the strict average. You just really could either take each of these stem and leaves, 10, and then add that to the next one, 15 plus 18 plus 23 plus 24. But essentially, you're just doing what this would be, just taking these numbers and adding them together, and then, of course, dividing that by the count, the 9 numbers, to get the average. So the average, the stem and leaf plot doesn't really help you find the average too much, but it does make it fairly simple to find the range, the mode, and the median. Okay? All right. So with that being said, let's just try a little bit of practice with this. Let's say I've got this list of numbers right here, and I wanted you to create a stem and leaf plot for this. Why don't you go ahead and take a piece of scratch paper and see how you do. Try to create a stem and leaf plot. And when you're done, you can compare it with what I'll get here, and then we'll see how you did. All right, so this is what I got for my stem and leaf. One thing I'm going to point out, and maybe you took this one step further, and that's fine if you did. It'll make it easier later. But you can kind of compare what you did and what I did. I simply kind of went through and wrote down them as I found them. Well, actually, I did mix these two up a little bit. But essentially, I just took my first stem was a 1, and then my leaf for that was a 1. And then a 1 and a 7. I put the 7 over here. I put my 2 2s over here. And then I went down to the 2 and 8. I took the 2 and then put the 8. 3 and the 1. 3 and then the 1. And I just went down the list, okay? So I didn't really try to write these leaves from smallest to largest, is what I'm saying. I kind of just made sure I got all these numbers in here and didn't worry about smallest to largest when it came to the leaves. Okay. Now you may have then taken this leaf section and reorganized so that all the numbers were from smallest to largest, like we did in the previous problem, and that's totally fine. You can certainly do that. I'm not going to do that only because I want to show you how to do the work of finding the mode and the median and so forth if the leaves are not ordered from smallest to largest. Okay? All right. So based on this stem and leaf plot, let's find our well, let's start with maybe our mode. Okay, so what's our mode? Well, again, we need to look for duplicates. So here I've got two 2's. So there's certainly a duplicate. And then I've got, do I have any other duplicates here? I've got two 1's. That's a duplicate. And that's all I've got. So far there's a tie going on here. I've got two 11's and two 12's. Okay. Over in the second stem here in leaf, I don't have any duplicates, and the next one I don't have any duplicates, and the next one. So again, we have a dual mode here, and the mode is 11 and 12. They both occur twice. Okay. So there we go. So there is our mode. Now let's go ahead and find our range. Take that next. Now the range, we need to find the smallest number. Now this is where you will probably have an easier time than me, and actually you probably had an easier time with the mode too if you organized these numbers. But I need to find the smallest number. So the smallest number is always going to be in the first stem. The largest number is always going to be in the last stem. Okay, so the smallest number is going to be this 1 in combined with the smallest leaf possible. So, of course, the smallest leaf possible would be a 0, but there aren't any zeros here. But we do have a 1. That'd be the next smallest leaf. So we have the 1. That's the smallest leaf in here. So the smallest number is 11. Okay? The largest number is pretty easy. There's only one 4, and that's 42. So the largest number is 42. So if we subtract 42 minus 11, we end up with 31. Right? So therefore, the range is going to be a 31. Okay? Excellent. Now, let's try to find, and again, I won't worry about the mean, but let's try to find the median. So how would you find the median? Go ahead and take a minute and try to figure that out. How would you find the median? All right, well, you're going to first count up how many numbers we have, right? That's important when we're trying to find the median. Well, if we count all these up, we'll find that there are 20 numbers. Okay? Now, to find the median, we need to find the middle number, but the other part of the median is that they need to be organized from smallest to largest, right? Because we're going to find the, well, in this case, because 20 is even, 20 divided by 2 is 10. So we're going to find the 10th and the 11th number and average them out. But we need to have this organized from smallest to largest, right? So I might just count this through and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th and the 11th number are going to fall somewhere in this stem, right, and leaf right here. Some two numbers here are the 10th and the 11th number, right? Because all of these numbers, even though they're not organized from smallest to largest, all of these numbers are definitely smaller than anything in this second stem, okay? And everything after the second stem is obviously bigger. So that 10th, and remember we're looking for the 10th and the 11th number. We're going to average those two, 10th and the 11th numbers. So the 10th and the 11th number is going to fall somewhere in here. So in this case, I am just going to quickly reorganize this set, this leaf set, so that they're from smallest to largest. So that from smallest to largest, it'll be 0, 1, 2, 0, 1, 2, 8, and 9. Okay, so that's from smallest to largest. So now I can go through and count again, looking for my 10th and 11th number. So I have 3, 6, 7, 8, 9 numbers here. So this is my 10th number, and this is my 11th number. So if I add those two up, 0 plus 1 is 1. 1 divided by 2 is a half, right? So the median is 1/2. All right, so hopefully you can see how that worked. All right, very good. We won't worry about the mean. These three are probably the ones that'll be working with the most. So, but again, just as a recap, you may have organized all of these numbers from smallest to largest, which is great. It's a little bit of initial work, but it does make finding these things easier. On the other hand, if you leave them the way they are, just kind of, throwing them where they land when you're writing them down, it doesn't really affect things too much. You do need to be careful and make sure you don't miss any duplicates because they're not going to be as obvious. They're not going to be right next to each other. The range, you just need to make sure that you do find in fact the smallest number and the largest number from the smallest and largest stems. And then the median, You don't have to reorganize everything from smallest to largest, but you need to decide which stem is the median numbers, the key numbers. In this case, they were numbers 10 and 11. Which stem is that going to fall into? And make sure that that stem is organized from smallest to largest before you select those, that 10th and that 11th number. Okay? All right, so hopefully that makes sense. Let's move on. Here I've got another set of numbers. I want you to go ahead and write a stem and leaf plot for this one, and then we'll look at it together. All right, so here we have some larger numbers, which is fine. And that's the reason I selected larger numbers is because I want you to see how to write the stem and leaf part to that. So remember, we have our stem and we have our leaf. Okay, the two parts. And the stems are going to be everything except for the last digit. Okay, so be careful. The last digit is going to be the leaves, or the leaves, excuse me. All right, so this first number, for example, if I just ignore the last digit, I have 20 left over, a 2 and a 0. So that is the stem. The stem is 20. All right, the next number is going to have a stem of 22 and 21. And if I just kind of read down, the smallest stem is going to be a 20. All right, so I'm going to write that stem first, 20. Then I can go through and say, okay, what other stems do I have? I have a 20, I have a 21, I have a 22, and a 23. So it's 20, it's 21, it's 22, and it's 23. Those are my my 4 stems. Okay, now the leaves for these, or the leaves, we're just going to go down the list. We won't worry about putting them from smallest to largest. So the first number, we remove the 20, the stem now. What do we have for a leaf? It's going to be a 6. The second one is a 22 with a leaf of 3. So we go down to the 22, the leaf is going to be a 3. 21, the leaf is going to be a 9. 21 again, the leaf is going to be a 3. And maybe I'll just even cross these out as I go through them here. 21, leaf is a 3. 22, the leaf is a 9. So we've got that one done. 22 again, the leaf is a 1. A 20 with a leaf of 8. 22 with a leaf of 0. A 23 with a leaf of 0. And a 21 with a leaf of 1. And a 21 with a leaf of 8. Okay, so there, I've got all my numbers accounted for. They're all in my stem and leaf plot. I haven't quite organized them maybe as well as I could have, but let's just take it as it is and go from there. So what would be the range? Let's start with the range on this one. What would be the range? Maybe take a minute here, decide what the range would be. All right, well, it's the largest number minus the smallest number, right? So what's our largest number? Well, it's going to be in our last leaf. And there's only one number in there, so that makes it easy. It's going to be 230 minus the smallest number, which is going to be in our first leaf. And we have a 20. We know it's going to be 20. And then we need to select the smallest leaf, which is going to be a 6. So 230 minus 206 is going to be what? 24. So the range is 24. Okay? Now let's find the mode. Find the mode for me. Well, let's look at it. So we have no duplicates, no duplicates, no duplicates, and no duplicates. So this one doesn't have a mode. No mode. Okay? Nothing occurs more than once. All right, then let's find the median. Now the median again, we need to, well, actually I won't tell you. You try to do it yourself first. See how you do. All right, so the median, we need to know how many numbers there are to start with. Now I could count these up, or I could just count my leaves, whichever one you want to do. I'm going to count my leaves this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 numbers. That's an odd number. So what are the two numbers we're looking for? We're looking for the 5th number and the 6th number. And we're going to average those two, right? The 5th and 6th number. Okay? So let's find them. So we have 1, 2, 3, 4, 5, and 6. So both 5 and 6 are going to fall in this stem and leaf. So I am going to order that stem and leaf from smallest to largest. So I have 1, 3, 8, and 9. And now I will recount to find my fifth and sixth numbers. 1, 2, 3, 4, 5, 6. So the 8 and 9 are the two numbers of interest. So I need to take 8 plus 9, divide by 2, right? I'm finding the average between those two numbers. So 8 plus 9 is 17. 17 divided by 2 is going to be 8.5 or 8.5, whichever you prefer. So the median is 8.5. All right? Very good. All right, now let's move on. We're going to talk about another way to look at these things. So let's take a stem and leaf graph plot, and that's going to be this one right here. So I've already written it up for you. I haven't given you the data. We could certainly, kind of work this backwards to get to the data if we wanted to. We would say that the data includes the numbers, 11, 12, 13, 14, another 14, 15, another 15, and 16, and then a 21 and a 22. We could certainly rewrite all the data if we wanted to, but it's already in our stem and leaf form. So that's great. Now the interesting thing to note here is if I were to take this stem and leaf form, such as I have right here, and make sure that every number is above they're in line with each other, right? I have these nice columns of numbers here. We can see that the longest column, that is where the most data fell, right? So, for example, if I think of, in terms of 10s, 20s, 30s, 40s, and 50s, the most data fell between 10 and 20 because I had an 11, a 12, a 13, a 14, a 14, a 15, a 15, and a 16. And that is the most data that fell between any, decade, you might say, between 10 and 20, or between 20 and 30, between 30 and 40, 40 and 50, and so on and so forth. So most of the data fell between the 10 and the 20. The least amount of data fell in the 50s, right? I've only got two 50s. I've got a 51 and a 55. That's it, right? So you can kind of see by looking at the stem and leaf plot, not only can we kind of work to find our mode, our median, and so forth, but we also get a feel for the data. We can kind of look at that data and go, yeah, most of the data falls between 10 and 20. So let's say this was, I don't know, let's say this is the weight of, a bunch of cats. Well, that's pretty heavy for cats, maybe. That's a really heavy cat that's at 51 pounds. So let's say that this is instead, the number of candy bars that a bunch of people tried to sell on their fundraiser. Okay, so someone sold 11 candy bars, someone sold 12 candy bars, and 13 and 14 and 14, and so on and so forth. Okay, so kind of thinking of it that way, you would say that most people sold somewhere in the teens. They sold, 11, 12, 13, 14, 14, 15, 15, 16 candy bars. All right. So most, I shouldn't say most people, but I should say the largest group sold, candy bars that were somewhere in the teens. Okay. And then the least number of people sold candy bars that were 50 or more candy bars. Okay. So if you kind of fell in that teen range, you could feel like you're in good company. A lot of other people only sold, that many candy bars. If you fell in the 50s range, you could feel really good about yourself. You sold way more than most people. Okay? All right. So very good. So that's kind of how you can see these stem and leaf plots and get an idea as to the kind of what's going on in the data. Now, what's interesting is if I take this stem and leaf plot, and what I'd like to do is, maybe we'll just do a quick copy here. This is the same one. What if we turn it on its side? So if we swing it over 90 degrees and set it on its side like that, it would look like this. Now, I have just taken that again and just kind of rewritten it here so that the numbers aren't sideways. So I've just kind of flipped all these individual numbers here so that they're readable. And then I flipped the stem so that it's, you know, underneath where the 1, 2, 3, 4, 5 are, where it should be, and so on. So if we look at what happened here, is you kind of get these stacks of numbers, all right? And the stack that's the tallest represents the stem that had the most leaves, right? That's where, you know, like we said earlier, that's where a lot of people tended to kind of to go, was in this first stack, in the teens, okay? So then taking the stack, these stacks of numbers, we can then turn them into a graph, which is called a histogram. And that's what we're looking at down here. So looking at this, you can see now these graphs are they're really wide. And unfortunately, I wasn't able to narrow them for you. So at first glance, this up here doesn't look much like this graph. But look at it a little bit closer. We have this first column here. And if you look at this first column, it just kind of runs all the way up to here, right? And you can see how that's higher than any other column in this chart. And if you look at the first column here, you can see how it is indeed higher than any of the other columns. All right. Here, the second column is actually the second highest. And again, second column, second highest. And that continues. We can see that that similarity continues all the way down. Okay. So, basically what we've done is we've just created a graph. Now, this graph shows the number. Oh, I actually put test scores here. So I guess not candy bars. I was thinking test scores when I made this, but we'll stick with our candy bars. So this graph would dictate or illustrate the number of candy bars. Or no, excuse me, the number of people that sold X amount of candy bars. So we should really fill in the bottom of this. This is 0 to, or actually not 0. Yeah, this would be 10. 10 to 20, and then this would be 20 to 30, 30 to 40, 40 to 50, 50 to 60. Okay, so this would be the number of candy bars sold. Okay, pen's going goofy here. Candy bars sold. Okay, and then this side we're going to call it, you know, I won't write it, but it's the number of people that sold that many candy bars. Okay, so if I have this range from 10 to 20, how many people sold candy bars in the range of 10 to 20? Well, if you look at the graph, follow this graph bar up, it lines up with the 8, right? So we would say 8 people sold candy bars, or sold between 10 to 20 candy bars. All right, and then it looks like 7 people sold candy bars, or sold between 20 to 30 candy bars. And then if we keep going down, only 4 people sold between 30 and 40 candy bars. Only 3 people sold between 40 and 50, and only 2 sold between 50 and 60. And that all lines up with this stem and leaf plot up above. Okay, so we've just made it even a little bit more legible. Now, what's interesting with this histogram is it gives you some general ideas, but it doesn't give you any specifics. So if I were to ask you, what is the mode of this data set based on this histogram, you wouldn't be able to tell me, because they're not giving you specific values. They're giving you ranges. They're saying inside here, there are numbers that range from 10 to 20, and they don't tell us what they are. Okay? Now, if you know, we had to know what they were, we'd have to look back at the stem and leaf and see that it's 11, it's 12. So there's an 11 in here, there's a 12 in here, there's a 13, there's a 14, another 14, 2 15s, and a 16. And those are the numbers inside this bar. But the bar doesn't actually tell us that. All right, it just tells us that there were 8 people, 8 numbers that ranged between 10 to 20. Okay. So the bar graph is the histogram. It's nice to look at visually. It kind of gives you an idea as to where most people fell. It seems like, again, like we said earlier, a lot of people fell in the teens. And if you didn't fall in the teens, you were more likely to fall between the 20 and 30. And if you didn't fall in any of those, you could keep going down. But the most unlikely place for you to fall would be between the 50 and 60. So it just kind of gives you some insights into what's going on with the data. All right, that is called a histogram. And we're not going to go into this too much. I don't think they're going to ask you to create histograms, but they're probably going to have you interpret some histograms. All right, so let's interpret some. Let's look at this histogram right here and try to pull some information out of it. All right, so this is a dog weights histogram. Okay, so basically we have the weight of a dog. That's the x-axis, the bottom here. So we have 10 pounds, 20, 30, 40, 50, 60, all the way up to 100 and, oh, there's a little bit of a, it would be 110 pounds at the very end. Okay, and then off to the left, the y-axis, this is the number of dogs that weighed that much. So if we look at this, we could say, okay, the number of dogs that weighed between 10 to 20 pounds were 5. There were 5 dogs that weighed between 10 and 20. All right. So just kind of looking at this, if I were to ask you, what category do dogs tend to fall most often as far as their weight, at least this particular group of dogs, you would say, well, it's going to be between the 80 and 90 pounds, right? Because that is where the most dogs fell. All right. And if I were to ask you, which category, or I should say, what's the least amount that most dogs in this particular group weigh, you would say, oh, they weigh between 10 to 20 pounds. Okay. All right. So let's answer some questions. So based on this histogram, how many dogs were under 50 pounds but over 40 pounds? So why don't you think about that for a second, see if you can come up with an answer on your own, and then we'll talk about it. All right, so how many dogs were under 50 but over 40? So here would be that range. The under 50 but over 40. So it's right in here, right? So how many dogs fell in this range? Well, if we follow this bar up, we find that there are 15. So 15 dogs weighed somewhere between 40 to 50 pounds. 15 dogs. Okay. Now, how many dogs were heavier than 100 pounds? All right, so see if you can answer that. All right, so we find the 100 pounds. Here's the 100 pounds. How many dogs were heavier than 100 pounds? So this is the range that we are looking for. So this would be, this bar. Where does that fall? That falls on the 10. I believe that's the 10. Let me see. Yeah, that'd be 10. It's hard to tell actually, but it's on the 10. All right, so there would be 10 dogs. 10 dogs that are heavier than 100 pounds. All right, what is the mode? All right, what is the mode interval? So be careful with this one, because remember I said earlier, you really can't tell what the mode is based on these histograms. However, they're asking for the mode interval, which just means what interval, what span of weights is the most common. Okay, and that's what we talked about earlier. Which bar is the tallest? So this bar is the tallest. So the interval that contains the most dogs is going to be the interval 80 to 90. So 80 to 90 pounds would be the mode interval. Okay, that's where most dogs tended to fall. Okay, very good. Now, last question here. Let me see if I can't just move this up here a little bit so we can still see our graph. So the question is, assume there were 179 dogs weighed. What percentage of them were between 80 and 90 pounds? Go ahead and try that one on your own. See what you come up with, and then we'll do it together. So first we need to find how many dogs actually were weighing between 80 and 90 pounds. So the 80 and 90 pounds, that would be right here, right? Between the 80 and 90. How many are in there? Well, there are 30 dogs in there. Okay, so there are 30 dogs that weigh between 80 and 90 pounds, and they want to know what percentage of the total is that. So you take the 30 out of or relate that to 179. 30 dogs out of the 179. Now that's a fraction that we can turn into a decimal, and from a decimal into a percent, right? So if I take 30 and divide it by 179, I am going to get, and I just did it on my calculator, so it's going to be 0.1676 roughly if we round. All right, so we have 0.1676. Now, if I turn that into a percentage, it's going to be 16.76%. So 16.76% of the dogs fall between 80 and 90 pounds. All right? Excellent. All right, I think that's probably a good place for us to stop. In general, you're not going to be asked a whole lot of questions on these things, but it is good to be familiar with how a stem and leaf plot works and how a histogram works, and be able to pull just some general information out of those. All right, so good luck on your seat work, and I will see you tomorrow.